So let's start off this. So the question is, how much heat would be needed to raise 15 grams of water from 10 degrees Celsius to 35 degrees Celsius? So first thing we can do is there are two ways to do this. One is we can go back to our previous heating curve. And we notice that we're going from 10 degrees Celsius to 35. And so 10 degrees Celsius would be like right about here. 35 would be right about here. And so this is going to be on this segment of the graph right in here. And since it's that segment, we know that we're going to use Q equals Cm delta T, like that. We know that the C is going to be 1.0, and so we can start off with those pieces of information. That's one way of doing it. Another way to look at this is simply to say that we know that there's a temperature change going on. It goes from 10 degrees Celsius to 35 degrees Celsius. There's a temperature change. Since there's a temperature change, the only equation that we have that has a temperature change is Q equals Cm delta T. Like that. So let's put this in here. We say how much heat would be needed to raise 15 grams of water from 10 to 35. So we're looking for how much heat. So we're looking for Q. We don't know what that is. We know that this is 10 degrees to 35 is liquid water. For liquid water, the specific heat is 1.0. The mass is M. It's 15 grams of water right there. And then we say we're raising it from 10 degrees to 35. The change in temperature would then be 35 minus 10, 25 degrees Celsius. So what we're going to do is we say get out the calculators there, and so you say 25 times 15, and so when you do that times 1.0 you get 375, and so from this that we know that Q, the amount of heat, is equal to 375 calories, and that's going to be our final answer. So it takes 375 calories to heat 15 grams of water from 10 degrees to 35 degrees. Our next problem says the addition of 73 calories to 105 degree steam will result in steam of what temperature? So what we can do on this one is we say that we have steam, it's 105 degrees. So since it's 105 degrees and it's steam, that means we're not changing the phase. We've just got steam just right there, just vapor, water vapor. And if we add 73 calories to that, it's just going to make the temperature go up. So we know there's a temperature change here. And so we know that because of that, we'll be using our specific heat equation. Q equals Cm delta T. And so from that right here, which would be capital T, we can say, okay, do we know Q? Do we know the heat we had? Yes, we do. It's 73 calories. So we know we have 73 calories. And then we say 73 is equal to C. Now, what is C for steam? So we look back to our specific heat of steam, and we see that. We see that the specific heat of steam is 0.48, then times the mass. And do we know the mass of this? Well, we don't. And so since we don't know the mass of this, we'll have to leave this as M as a mass right here. And let's say for the purposes of doing this, let's say that the mass of this guy right here is, I forgot to put this in the problem, let's say that the mass of this is, we'll say that we have 20 grams of steam. And so instead of putting an M in here, we're going to put 20 grams. And so we have 20 grams of steam, and then times the change in temperature, which we do not know. We don't know what the final temperature is, so we don't know what the change in temperature is. So we have this right here. So at this point, we have 73 equals 0.48 times 20 times delta T. So we're going to want to solve for delta T, and so we'll take 73 calories. And once we've got those 73 calories, you're going to divide it by 0.48, and then take that and divide it by 20. And we end up with, I get delta T to be 7.6. So we get delta T is 7.6 degrees Celsius. Now, this is the change in temperature, not the final temperature. Since the original temperature was 105 degrees, we'll take 105 and add 7.6, so we get a total of 112.6 degrees Celsius as our final answer here. Significant figure-wise, this ought to be around probably to 2 significant figures. So really, if we're doing this, it probably ought to be 110 instead of 112.6. But right now, we're just taking you through the basic operation of how this works. These would be 2 examples of how we would do problems that deal with specific heat. Let's take a look at the next possibility, which is latent heat. And so if we had a latent heat, that would mean that we basically have a phase change. And so looking at our phase changes here. So how much heat would be needed to completely melt 12 grams of ice? And so we said we're melting this. That's a phase change. If we have a phase change, we want to equal Q equals MHL. In this particular case, we're melting, so this is going to really be not HL, but rather be HF, the heat of fusion. Now, this question is how much heat? So we don't know the heat, that's Q. Do we know the mass? Yeah, we do, it's 12 grams. And then we said it's HF because we are melting this ice, and so we have to figure out what HF is for water. And if you look that up, it's 79.7. So we know 79.7 is what we have here. So to find the total heat, we take 12 times 79.7. So 12 times 79.7 is going to give us 956.4. So 956.4 calories is the amount of heat needed to melt 12 grams of ice. Now, significant figure-wise, we have 2 sig figs right here, and so we'd have to round this final Q to 960 calories. And that would be our final answer. So 960 calories to melt 12 grams of ice. Try another one. Next one. 1,000 calories would vaporize how much 100 degrees Celsius water? Now, key word here is vaporize. If we're vaporizing, we're changing phase. And so if we're changing phase, we're going to use Q equals MHL. In this case, we're vaporizing, so this HL is going to be HV right here. Let's take a look what we know. Do we know the number of calories? Yes, we have the heat. So we know it's 1,000 is the number of calories we start with. And this is equal to the mass. Do we know how much mass we have? 1,000 calories of vapor is how much? We don't know the mass, so that's going to be M. And then 100-degree water. So we now know what the HV is. And if you look for water, that the heat of vaporization is 539. So we say 539 here. Solve here. We're going to divide both sides by 539. That's going to cancel on this side, and so we get a mass of 1,000 divided by 539. So if you take your calculators out, you say 1,000 divided by 539, and so that gives us a total of 1.855. So we get 1.855 is going to be the grams. Really, we don't have the 1,000 is spelled out, so that's exact. 100 degrees Celsius water's got one significant figure based on that, but really it's exactly 100 degrees, so that really doesn't affect it. The numbers we put in here, really we don't have, nothing tells us significant figures. We all get things exact. So you actually wouldn't want to round this at all based on the number of sig figs that we have in this particular problem. So 1.855 grams of water is our final answer here. So that's what we got for heat calculations in that sense. And so that being said is that that should finish our lesson up here. And so next time we'll come back and we're going to talk a little bit about what happens when you change phases. You go from like solid into liquid, and then you have to do things on not just specific, not just latent, but on both. So that'll be our next topic.